Okay, we're still in Algebra 2, and we are actually at the end. This is our final section of Chapter 1. So after this, we will begin reviewing for our test in Chapter 1. So Section 1.6, solving compound and absolute value inequalities. So last section, we were solving inequalities, and I think I probably should have written each of the answers in set builder notation, but that's okay. We'll make up for it in this video. And this time, we're going to be talking about compound inequalities, intersection, and union, and I'll use some kind of examples to kind of get through some of these concepts that are a little silly, but we'll see how it goes. All right, so a compound inequality is when you're not just comparing the answer or even an expression or a variable to one thing, but you're comparing it to two things. And we talked about that in the last video. So if 2 is less than or equal to x and x is less than 7, this is a compound inequality because it's not just x being compared to one thing, it's x being compared to more than one thing. And you'll see here an example 1 that we have a compound inequality. This is considered an and inequality because when it's written like this, we're assuming that both things can happen at the same time. This and that. X is greater than or equal to -2, and x is at the same time less than 7. So both can happen at the same time. Another type of compound inequality is that we might get an or inequality. So that situation would look like this. X is greater than 7 or x is less than 2. And usually when there's or, I mean, if it's written correctly, we cannot have these two things happening at the same time. So imagine, can x be bigger than 7 but at the same time smaller than 2? No. So we say that this is an or situation. X is either this or it's that. And this is kind of an and situation where x is this and that. It is greater than or equal to 2 and at the same time less than 7. All right, so basically what these two words really mean is that intersection is where two things overlap, and in a sense we're looking at an intersection in this case. And a union is where we're taking two things that are different and we're joining them together. So this is a union of x being greater than 7, all of those answers, and x being less than 2. So this is a union and this is an intersection. And my silly example is I think about parties. And if you know me, we may know a couple people in common, right? And if we know a couple people in common and we decide to have a party, the intersection of our guests would be the people that we have in common. So we could have a party and we could say we're going to invite the only people we're going to invite are people that we both know. So it wouldn't just be people that you know, if you wouldn't be just people that I know, it'll be people that we both know, the intersection of the two. And that's what's happening here. So in a sense, let me use the black pen, in a sense, this is one group of members of the party, all the x values that are greater than 2. And then this is another group of possible members of the party, all the x values that are less than 7. But since we're having our party together, we're going to do the intersection of 2. You have to be both less than 7 and greater than 2 to come to this party. Does that kind of make sense? Union's a little bit different. It just means all of your friends and all of my friends, we're just going to bring them together. So we could be people that are your friends, x greater than 7, or people that are my friends, x less than 2. All right. Hopefully that kind of makes sense. In my mind it's straight, but sometimes when I go to analogies it sounds crazy. Let's get started with some examples and maybe that'll clear up any confusion that we have. So when we're solving compound inequalities, your textbook talks about two different methods that we can use. I will probably err on the side of the first method, meaning I'll use the second method rather better. But you could do this. You could write this part separately and then write this part separately as well. Treat them as two problems where you're going to include where you want both of these intersect together. So and here is kind of a funny word. It means you want the intersection of two things. So and in math is kind of funny. It's actually exclusive. So what do I mean? Like, let me try one more example. If I said I wanted to marry a man that was tall and rich, that means I'm not just accepting tall people. I'm not just accepting rich people. I want you to have the quality of being tall and rich. Whereas the or is more of a union. I'll take two groups. I want a man that is tall or rich. So it doesn't matter. You could be tall, you could be rich, you could be tall and rich. I'll take them all as long as you fit into one of those categories, okay? So and in math is actually more restrictive. You got to have both qualities. So I'm going to solve both of these separately, and I've got to have both qualities. Remember, solving inequalities is a lot like solving equations, where we just make sure we choose a side where we want our constants, and my choice was this left side to have my constants. Dividing both sides by 2, it's all good because 2 is a positive value. X is greater than 3, and so that's part of the answer. So I want this, and at the same time I need this over here. So check it out. I'm going to add -7 to both sides, choosing for my constants to be over my here and my x terms to remain here. When I do that, I get that 2x is less than or equal to 10, and therefore dividing both sides by 2, x is less than or equal to 5. And so now for both of these things to happen at the same time, do they want me to graph it? Yeah, graph. For both of these things to happen at the same time, let's graph them individually and see where they overlap. So graphing each of these inequalities separate, we see we have an open circle and we're shading to the right because x is bigger than 3, 3 is less than x, and here x is less than or equal to 5, so x can certainly be 5 and then it's anything less than. But I don't want to include just one or the other. I'm not just bringing everything together. I only want what is the same in both of these. So I'm looking at this overlapping area, and they overlap not at 3 but beyond 3 up and equal to 5. So my answer would be x is somewhere between 3 and 5. Now I probably would not actually do these two separate problems. I'm going to look at this way of doing it in example 2, and I'll show you this is what I do. So starting again with the very same problem, instead of separating them, I'm just going to do the same thing to each of these 3 sections. So I look at it as if I've got this section here and this section here and then this section over here, and I'm just going to do the same thing to each section to maintain this particular type of relationship. So if I add a -7 here, because my goal is to get the x term by itself, add a -7 here, add a -7 here, I'm going to get a, not 6, but 5 is less than, did I change the problem? Oh, it's 13, I'm sorry. I'm going to get 6 rather, sorry about that, is less than 2x, because that's gone away, which is less than or equal to a +10. At this point, I'm going to divide everything by 2. Notice I'm dividing by a positive number, so none of the signs flip. And when I do that, I get 3 is less than x, which is less than or equal to 5. And I come to my answer very quickly, and I can graph it just as I see it. Oh, the key numbers here would be, here's 0, here's 3, here's 5, and I'm going to have an open circle here and a closed circle here, and I'm going to only shade what's in between because that's what the solution is. If I were to write this in set builder notation, I'd write all x such that x is between greater than 3 and less than or equal to 5, and I'd rock a curly bracket over here to end it. Let's take a look at this next example, example 2. Solve an OR compound equation. So when you have an OR compound equation, you pretty much you have to solve these separately and then just join all of it together because this is a union. I'm just bringing 2 things together, this or that. I'll take either one. So here, if I'm going to answer this question, I am going to get rid of the 2 by adding a +2 to both sides, and I get that y is greater than 3 plus a -2, -1. So that's one part of my problem, and over here I'm going to get rid of the 4 by adding a -4 to both sides, and then I get y is less than or equal to -7. So I can graph these separately and then graph them together. This is the way we'd write the answer though. So I could write my set builder notation y such that y is greater than -1 or y is less than or equal to -7. Both are acceptable, and so when I graph those, I'm going to graph both of those concepts together and see what it looks like. So if y is greater than -1, here's -1. Let's put -1 over here, because I'm going to be dealing with -7, 0 somewhere over here. So -1 is here, y is greater than that, open circle on -1, shading everything to the right because y is bigger than that. And then y is less than or equal to -7, so solid circle because it can equal -7, and I'm shading like this. All right? Okay, let's take a look at example 3. In example 3, we're now dealing with inequalities. And so inequalities are a tricky little guy, but when I have an inequality like this, I'm going to show a quick way of dealing with it. When the inequality is less than a value, what I can do is I write the same problem without the inequality, and then I write the symbol, same symbol here, exactly. I don't turn it around. And then I write -4. And the reason why is because, let's just think about this. If the absolute value of 4 is less than, if the absolute value of A is less than 4, that means that, remember absolute value being the distance from 0, that means that the answer must lie somewhere between -4 and +4, right? If you think about it, it totally makes sense. So, you know, if I'm all up in here, up in this section, if I do like -1, absolute value of -1 is less than 4. Yep, absolute value of all the way up, can't include that 4, but if I do -3.975, absolute value of that is less than 4. Positive, yep, absolute. So we can think about it intuitively and say, yeah, the answer has to be somewhere between -4 and +4. And so we write this. Now that we've got that, we're really done. And actually we're kind of done because I already actually graphed it as well by trying to illustrate what it means. And so the only thing I have to do is just make sure I have an open circle here because A does not equal 4 or -4, but it is some answer in between. All right? So let's take a look at another example because inequalities can be a little tricky. So here, this one's a little different, right? We've got the absolute value is greater than some number. When that is the case, again, let's take a look at the number line and consider what it is we are doing in a type of problem that is like this, that's set up like this. Well, the absolute value of A must be greater than 4. That means that the value must be further away from 0 than 4. So in this case, we're talking about values that are beyond 4. But we can't forget that we can also be referring to values that are beyond -4 in the negative direction. And so in this case, we're not including -4 or 4, but we are including everything that's beyond that value, beyond those two values, because that's going to give me the absolute value of which is greater than 4. And so since we have it like this, our answer, whenever we have a break in our graph, we know that we have an or situation. So the situation that we have here is that A is, watch this, greater than 4, or A is either greater than 4 or A is less than -4. A is greater than 4 or A is less than -4. And sometimes I tell students to do exactly the same thing. Write it down just like that, where you're writing the same symbol twice and you're putting the negative on the back end, and then you have to ask yourself, does this make sense? Can -4 be bigger than A and at the same time A be greater than 4? No, so we write it as an or. So that, after I write it like this, I then break it down because it doesn't make sense to write it like that. I write it as two separate values. Let's see if we can apply this to this problem here. All right, so here we have a situation where we've got 3x minus 12, and I've got this symbol. I'm going to write the symbol the same way on both sides, 6 and a -6. I ask myself immediately, can this be done at the same time? Can this thing be less than -6 and at the same time greater than 6? When I see and I say that doesn't make sense, you can't be bigger than a big number and then smaller than a small number at the same time. This tells me I've got an or situation. So it looks like I'm going to have to make a second video because I see our time is running out. So we'll pick up with this example in the next video.